So today we are going to talk about solving exponential function word problems. And these are word problems in which we see a rapid increase or a rapid decrease of some type of quantity. Most often, these types of word problems focus on money, such as an increase of money when you put it in a savings account at a certain interest, or unfortunately, an increase of money that you owe on a credit card or on a loan. So we're going to talk about two different equations that could be used to solve these types of word problems. The first is A is equal to P times 1 plus or minus R over N, all raised to the NT. Or the second is A is equal to P E to the RT. Okay, so we have to first identify which one we're going to use and how we know which one we're going to use. And the best way to identify that is the second one is only used if somewhere in the problem it says compounded continuously. Okay, compounded continuously. Otherwise, we're going to use the first equation. Now, with the first equation, you also have to make the decision of whether you're using plus or minus in the formula. Now, the key to that is you're going to use plus when you see the word accrues, or pays, or makes, or increases. Okay? And you're going to use minus when you see decreases or goes down. All right? So looking at the word problem without identifying anything other than what kind of formula you're going to use always happens first. Then you're going to have to identify what each of these unknowns stands for in the word problem. So A stands for the final amount, and that's found in both equations. P stands for the initial amount. So how much money do you start with on an account? Or how much money do you have on your credit card bill? Or what is the original population? Okay. R stands for the rate, and this is always going to be in decimal form. So the key to that is you're going to have to convert your interest rate, or the rate that the population is increasing, or the rate that the population is decreasing, into decimal form. Time is in reference to years. Okay? And if we use the first equation, we have to identify N. And N is the number of times the rate is compounded. Now, this you determine by specific terms. Okay? If somewhere in the equation it says annual or yearly, then we know our N value is going to equal 1. It could say semi-annually, and N equals 2. Okay? It could say quarterly, and there N equals 4. It could say monthly, and in that case, N will equal 12. It could be weekly, and in that case, N will equal 52. And it could be daily, where N equals 365. Now, once again, you're only going to use these values if you're using the first equation. The second equation has a special unknown, and that's E. But E is a constant, just like pi. Okay, and it is programmed and found in your calculator. All right, and you'll be able to obtain it by hitting the button second ln. Okay, and that can be found all in the first column. So let's look at some examples together, all right, to determine what equation we're going to use and how to solve. So the first example is, suppose you deposit $2,000 in a savings account that pays interest at an annual rate of 4%. If no money is added or withdrawn from the account, how much will be in the account after 3 years? After 18 years? Okay, so let's think about this. Does this say compounded continuously anywhere in the problem? It does not. So we know we're using the first formula. A is equal to P times 1 plus or minus R over N, all raised to the NT. Now, after we decided that, we have to determine whether it's plus or minus. It pays interest. It's adding value. So we know it's going to be addition. Okay, so the actual equation we're going to use is A is equal to P times 1 plus R over N to the NT. Now we have to identify what we know. Suppose you deposit $2,000. So that's our starting amount, $2,000, into a savings account that pays annual interest. Okay, annual interest. Well, that tells us right away our N value is 1. Our rate of 4%. Well, 4%, we have to convert that into a decimal, all right, which means that our rate is going to be 0.04. If no money is added or withdrawn from the account, how much will be in the account after 3 years? Okay, so that is our time. Time is 3. So we're going to plug this all into our equation. A is equal to 2,000 times 1 plus 0.04 over 1 raised to the 1 times 3. So A is equal to 2,000, 1 plus 0.04 raised to the third. And you're going to follow the order of operation to solve this. Okay? And if you were to follow the order of operation, after 3 years, the final amount would be $2,249.73. We're dealing with money, so we know we round to the hundredths place. Now, what's the difference with how much will be in the account after 18 years? Well, still starting amount of 2,000. We still have an annual rate. The rate is still 4%, but in this case, the time is 18 years. All right, so A is equal to 2,000 times 1 plus 0.04 over 1 raised to the 1 times 18. So A is equal to 2,000 times 1.04 to the 18th power. So once again, we're going to use order of operation and find that after 18 years, if no money is withdrawn or added, there will be $4,051.63. So putting money into this savings account is great. You're making free money. Okay? Now, realistically, savings accounts do not have this high of interest rates. They typically have interest rates more in the 0.5%, lower than 1%. Okay, let's do another one together. The population of a certain animal species decreases at a rate of 3.5% quarterly. If the population starts with 2,500,000 animals, how much will be there in 4 years? Okay, so does it say compounded continuously anywhere? It doesn't. So we're going to use the first equation. A is equal to P times 1 plus or minus R over N raised to the NT. Now, we have to decide whether it's positive or negative. And in this case, it says the population is decreasing, which means that it's going to be negative. So we're going to use the equation A is equal to P times 1 minus R over N to the NT. Now, my question to you now is to identify what the given values are for this equation. Okay, so we know P stands for the initial amount, which in this case is 2,500,000. Okay? R stands for the rate, which is our percentage in decimal form, so 0.035. N is given to us by a specific term, which is quarterly. So N is 4. And time is how much time goes by, and that too is 4 because we have 4 years. So now we're going to plug this into the equation. A is equal to 2,500,000 times 1 minus 0.035 divided by 4, all raised to the 4 times 4. So you're going to use order of operation to solve this. Okay, you're going to use order of operation to solve this. And you should get an answer of 2,172,056. This does not have any form of a decimal because you're talking about an animal, and you can't have a fraction of an animal. You also don't round up because you can't have a fraction of an animal. All right? So now I would like you to do this entire problem on your own. Mrs. Halverson invests $5,000 into a savings account that accrues 2.1% interest compounded monthly. How much will be in this account in 10 years? Okay, identify which equation you're going to use, identify the knowns, and solve for the unknown. Okay, so for this problem, you are going to use the first equation because it does not say compounded continuously. Now, because it says accrues, we know that we are going to use the addition. So our actual formula is going to be A is equal to P times 1 plus R over N raised to the NT. So our P value is $5,000. That's how much I invested into my savings account. My savings account accrues interest at 2.1%, which is converted to 0.021. It's compounded monthly, which means my N value is 12, and I want to know how much money is in there in 10 years. So then I'm going to plug all this in to my equation. And then I'm going to plug that into my calculator, and after 10 years, this account is going to have $6,167.26. All right, let's look at another example together. Suppose you won a contest at the start of 5th grade that deposited $3,000 into an account that pays interest compounded continuously. Oh, there's that key word, compounded continuously, which means that we have to use the second equation. We have to use A is equal to PE to the RT. How much will you have in the account when you enter high school 4 years later? Okay, so what do we know? We know that the starting amount is $3,000. We know the interest rate is 0.05. We know the time is 4, and that's all we need to know. So A is equal to 3,000 E raised to the 0.05 times 4. And we're going to plug that into our calculator. Once again, the E can be found when you press second LN. And you get $3,664.21. And remember, we can round up here or round down because we're dealing with money. All right, I'd like you to do this last example on your own. Okay, so because it says compounded continuously, we know we're going to use the second equation. A is equal to PE to the RT. We know our initial amount is $8,000. Okay, our rate when we convert 0.25% into decimal is 0.0025, and our time is 6 years. So A is equal to 8,000 E raised to the 0.2, oops, sorry, that's my mistake, raised to the 0.0025 times 6. If you plug that into your calculator, you will get $8,120.90. That's it for today. Have a great day.